Hi and welcome to ORICtober, a series of videos celebrating the Oric computers from the 1980s in October 2021. This is a very abridged version of a video I wanted to do about high resolution and text mode graphics, how to mix that using attributes. I talk about attributes in other videos just to give a higher level introduction without going into too many details. And then I did a really long video which was 17 minutes plus long, and I don't think many people will want to spend all that time looking at it, but I do try to explain what's going on, but maybe it's too long. So this is going to be a much faster and shorter video, and I've captured my thoughts as a program, so I can really talk through the program to explain what's going to happen. So fundamentally, I'm going to use that top status line of the Oric screen to demonstrate mixing high res and low res modes together on the same row. First thing I'm doing here in line 10, 11, 12 is that for 8 scan lines of the high resolution screen at position 5, at column 5, I am switching to text mode, and that's in anticipation for when I go into high resolution mode that we need to, when we're in high res mode, move back to text mode. So A00 is the base address for the high resolution screen. Then what I'm doing is in the same high resolution screen area for 8 scan lines, I am poking a background color just as a starting point to show that it works. And then, well, in fact, this is not really going to be seen when I run the program, but that's what I'm doing anyway. In column 1, so A001 for 8 scan lines, I am putting in the background color. And then in line 16, 17, all I'm doing there is poking 64 into columns 2, 3 and 4 of scan lines 0 to 7, just to remove any garbage. And then in line 18, BB80 is the start address of the text screen, and I'm poking 1E in there. 1E is the attribute code to go into high resolution mode. Now, I'm going to pause here and just explain what's happening. When the graphics chip, the ULA of the Oric, starts, its display is by default in text mode, so it will start at BB80. So therefore, it starts at column 0 at this base address, and it sees 1E. And that means go to high resolution mode. So it goes into high resolution mode, which is base address A00, and then it continues from there. Now it's at column 1 though, so it's actually reading from A001, and it will continue until it gets a different attribute to change it back to a different mode, which is what we see here. So that's why in A001, which is the first high resolution byte it reads, I'm just poking in some text, some attribute to change the background color, and then it proceeds along A001, 2, 3, 4, and when it gets to 5, it meets the attribute, the code 1A, which is the attribute to tell it go back to text mode. And in between, columns 2 to 4, so A001 contains a color attribute, then 2, 3 and 4 contain 64, which is actually just show nothing. It's 64, only the lower 6 bits are displayed, so that's all 0. But you have to have 64 to tell it it's not an attribute. And then it meets at column 5, it meets 1A. So it's going then back to text mode from column 6 onwards. So column 6 will be in text mode. So bearing that in mind, what I'm doing here on line 19 and 20 is just poking hello world into the status screen. I'm actually starting at column 9, but let's do column 6, because I just mentioned that column 6 onwards is text mode again. So let's clear the screen and have a look at that. Make sure it looks right. Yeah. So all I'm doing up to line 21 there, 18, 19, 20, 21 is poking hello world. And then I've just got a little loop really, which just shows all the colors from 1 to 7, and then just keeps going. And what it does is it pokes those colors into column 1 of each row of the high-res screen. And what that means is that we will see a kind of rotating rainbow effect. Anyway, let's do it. I hope that makes sense. Okay, so basically when it's in text mode, the ULA, it always knows which column it's in, and it also knows which row it's in. But in text mode, it's the same row in terms of memory for 8 scan lines, whereas in high-res mode, it's 1 row per scan line. So it then uses that row, scan line, and column index, if you like, offset from either BB80 if it's in text mode or 8000 if it's in high-res mode to read the next byte. So that's all it's doing. So you just have to basically make sure you've got the right bytes in the right bit of memory so that when the ULA switches mode, it will interact with the right bit of memory and you switch back as you require it and do whatever attribute change it wants. So let's run it anyway because I'm really talking too much. So you saw briefly there the background effects from line 16, 17, sorry, line 13, 14, 15. So what's going on here? When you saw the background and also this effect here, when the Oric is switched into high-res mode, and then when what we do, I'm going to stop the screen for a moment, stop the animation, and when we go into high-res mode and we poke in column 1 a color, in fact let's use this one here, line 25, we poke a color, the ULA only has a certain amount of memory. Well, it only has memory of what should the foreground color be, and we set the foreground color here. And then even though by column 5 we switch back to text mode, it still remembers the current foreground color, and so it displays the rest of the text for that, just that scan line in that color. And then when it tries to display the next scan line, it meets that BB80 byte again, and it's 1E, so it goes back into high res, but it's now on the next scan line down, and then there's an attribute in the high res memory map which changes the color to a different color from what it was in the previous scan line, and even when it moves back to text mode, it holds on to that color. And that's why you can basically have low resolution or text mode characters basically having color change by scanline. So that was a terrible description, I reckon, but maybe it's helped somebody. But it kind of shows that you can do some quite nice effects, much nicer than what I'm demonstrating here with some clever programming, even though attributes does seem quite limiting at first sight. So I'll leave you with the animation.